Welcome to the distance learning program presented by Innovus on Java Servlets. Before knowing Java Servlets, it is interesting to know about developing a web application. Developing a web application is a dynamic extension of a web or an application server. There are two types of web applications, presentation-oriented and service-oriented. Presentation-oriented web applications generate interactive web pages containing various types of markup languages like HTML, XML, and so on, and expect a dynamic content in terms of response for all the requests made. Whereas service-oriented implement the endpoint of a web service. Let's see how web applications work generically. We have user client-side interface, which is nothing but web browsers, server-side processor, and a data source. First, the user defines a query using the query interface. It means that web applications provide users with an interface for entering the data. The data they enter is usually called as query or a request because the user-defined data is used for dynamically query or make a request from some service on a web server machine. Once the data is collected, the user data is sent to the web server. The web server later processes the user data using some sort of middleware or a backend service, after which the data source returns query results. The returned query results are sent from server-side agent to the client side. Finally, the written data is displayed to the user, which can be in terms of HTML or a complex performing calculations, sorting, or other manipulations of the data. This is how normal web applications work. The web technology will fall into category where we can see many layers involved in it. Initially, the user will interact with GUI layer, which is graphic user interface layer, which is nothing but the user interface layer where the user can enter the data or do any kind of manipulation with the interface. After which it goes to communication layer, middleware layer, and a data layer. We'll see in details in further slide. This is how the web application will look like. All the tools which fall into web applications will come under each layer. Here if you see, there is a user who is interacting with the GUI layer. The GUI layer must translate the desired intention, needs, or wants of people into executable logic machine instruction. At the same time, the GUI must also translate computer-generated data into meaningful human-readable information. Therefore, creating web applications, web developers will spend more time in designing the front end rather than designing the back end. Therefore, GUI layer is foremost very important in web applications. Next, we have a web browser, which is a software program that knows how to contact a web server using HTTP protocol, a request given document from the web server, and a display that document written by the server to the human user. This is done by the web server. After the user has submitted whatever information they need to submit into whatever GUI you have designed, it is time to get that information from browser to the server. So here the protocols come into picture. The information has to pass through the communication layer using these communication protocols. So now we have seen how user requests are gathered by the GUI layer and how they are sent across the wire to a web server by communication layer. The purpose of middleware layer is to accept incoming requests and process them using the resources provided by the web server, the machine that the web server runs on, or by the network of servers and resources that the web server is connected to. Consider most basic function of a web server, distributing HTML files. In this case, A web server requests a given HTML file from the web server. In response, the web server will find the given file on local file system and send it back to the browser. So important to think about the middleware layer, a network of resources that are tied together by network protocols and distributed objects, which are nothing but DCOM from Microsoft and Corba from Open Systems or C++ and RMI from Java. These are all the network protocols essentially provide access to objects no matter where they are on the network. After which we have the data layer, which involves XML, HTML, raw data and CSS XSL. The data in the data layer that is being manipulated can be in any form. It can be in terms of values, data will have types, data have descriptions and also different kinds of formats. So this is the foremost important flow of layers involved in web application. It will involve all kinds of layers. As we saw in earlier slide, the user goes through GUI layer, which is graphical user interface layer, and then communicates through communication layer involving many protocols like HTTP, HTTPS. Finally, it goes to middleware layer where the Java servlets, ASP, active server pages, CGI, common gateway interfaces, or any kind of LDAP, file system services will be used with along with network web server resources, and finally the data layer performing different kinds of data involving data values, data types and many other features. Next we see the history of web programming. What is this web programming and how it got evolved? Here we have an HTML for the beginning, which was great for distributing pre-prepared web pages on request. HTML was designed primarily for web browsers and web servers to exchange HTML documents. Thus, by definition, HTTP is not very dynamic. It means Hypertext Transfer Protocol is not very dynamic. Here if you see a scenario where HTTP to ask the web server for a specific HTML document, the web server would then send the request document back to the web browser, which in turn would display the document as defined by the HTML to the client. HTTP was defined primarily for web browsers. Therefore, it's already told earlier, HTTP was not very dynamic. For example, you would have to generate a clock that would always show current time when it's loaded. Any page, you would need to set this feature where it shows the time and date. To do that same thing with HTML, an HTML author would have to edit the HTML document every second with the new time. So this was a major drawback when you use HTML and therefore it was not very dynamic. Therefore, the birth of server-side programming came, that is True Common Gate Interface, what we commonly known as CGI. The CGI script, on the other hand, can access the time date resources of the operating system in France on and independently output the current time whenever it is called without the author even having to do anything. Therefore, it being dynamic. You can see an example, it does dynamic, and that's how CGI came into picture. This is the history all about common gateway interface. Here if we see the browser contacts server using HTTP connection over the network. Browser was nothing but a client. It will connect to the internet through HTTP. HTTP will further go through web server software which executes CGI script. CGI scripts will then go through email databases and operating system commands which uses server hardware resources. The CGI script after which creates HTML page with dynamically obtained info and further which the web server software sends the browser the HTML prepared by the CGI script. This is how the common gateway interface normally works, where client does go through server. To continue with, CGI came with many drawbacks, like it was very much involvement of problems in CGI. It caused many problems, like it introduces security holes, private or confidential documents stored in websites, documentary may fall into the hands of unauthorized individuals. This was the reason behind security hole. Private and confidential information sent by the remote user to the server might be intercepted. The information can be a credit card information or any confidential information. So all these led to introduce security holes in common gateway interface. CGI was ugly and is ugly because CGI scripts produce fairly ugly user interfaces. Basically, CGI is limited to bland HTML based forms, and whatever bells and whistles can be provided by HTML layout. Therefore, due to all these disadvantages, it also had one more additional called difficulty in sharing resources such as common login utility or server-side object between different requests. Due to all these disadvantages, next came the server-side includes based technology, which is called as SSI. The concept of SSI is simple. An application developer codes special tags into an HTML document. And this was all about server-side includes. Those special tags are understood by the web server and can be translated on fly by the server as an HTML document passes through on its way to the browser. The developers are limited to the range of commands or tags. This was a drawback offered by SSI-enabled web server provider. And this is the workflow, how the SSI work. As it says, it's a server-side includes. In web server, if you see, it just takes the HTML document with the tags which says execute command equal to date, which is then executed by SSI substitution, and the date will be replaced by the date and time and responding to the web server or web browser, back to the client or the end user. SSI had this drawback of limiting to itself by creating the range of commands or tags offered by it. So there was a limitation for creation of the tags. After which came the active server pages. So these are the active server pages which were used for developers to code custom tags, and this overcome the server-side includes problem. So it started creating the custom tags in JavaScript or VBScript. Later we have server-side Java. One of the preferred languages for doing so is Java. There are two primary ways to do this: Java servers and Java servlets. So Java servlet is one of server-side programming. Server-side Java with servlets allow you to embed a Java server service through the web server. Next, we see what is this web infrastructure setup. For development of any web application, we need to have the proper infrastructure provided with generic web application setup. We'll look into it detail. Web application lifecycle. Before that, it's important to know how the process are involved in creation of web application. The process for creating, deploying, and executing a web application can be summarized in following order. Develop the web component code. Develop the web application deployment descriptor. Compile the web application components and helper classes referenced by the components. Optionally, package the application into a deployable unit, which is very important to deploy on the server, especially for server-side programming. Deploy the application in a web container. Access a URL that references the web application. So this is the basic structure involved in web development of any application. We see an assembly root which gives two branches, web INF and web pages. In web INF, we have web.xml, which is deployment descriptor. Can be for any server, but this is the basic structure. Then we have a lib having all kind of jar files. We have classes. These classes will have all .class files for Java, which are involved in development of web applications. And the web pages, which we call as JSP, HTML, JSF, all kinds of web pages are put in web pages folder. You can name any kind. The name can be anything specific to modules or user defined. But this is the basic structure where you place all kinds of files to get the web application up. And this is the beginning step to summarize how the process is gone in detail. Packaging a web module. So as you saw earlier, we have web INF classes folder which involves all combined Java classes, which is the directory of a web application. And this folder will involve all Java source files compiled classes. And there is the lib which contains .jar files. Next is deploying a web module. Deploying a web module is involving using through Eclipse, one of the IDE integrated development environment, or using through Ant utility, or also it can be through administration console. Next is updating a web module. A typical iterative development cycle involves deploying a web module and then make changes to the application components. You can make changes when it is deployed. Then to update a deployed web module after deployed, if you make any changes, it involves following steps like recompile any modified classes. You have to recompile them again, redeploy the module, reload the URL in the client. That is, in the browser, you need to refresh the page or reload the URL to see the reflection of your changes made. Continuing with the infrastructure setup, next we have configuring web applications. Web applications are configured by means of annotations or by elements contained in the web application deployment descriptor. So it means that the web.xml what we saw earlier, which is nothing but web deployment descriptor, it involve or contain all kind of configuration details of web applications. Currently, in latest versions of any kind of web application, we have configurations through annotation, which is the latest feature for web applications, which can be configured through program using annotations. We have mapping URLs to web components. A URL path contains the context root and optionally a URL pattern. So this is how it looks. We have a protocol, which is hypertext transfer protocol, and a host, port number, and the context root where the project is present. As you saw earlier, the assembly root or the base root where we have the project, and the URL pattern. How we want to see the page, this is the URL pattern at the end of the URL. Next, we see the purpose of using servlet in JEE. JEE 6, that is Java Enterprise Edition 6 specification was finalized in December 2009, and it was bringing new and updated features to the world of enterprise application development. Servlet was there in JEE environment from past it came into existence. but this is according to the latest specification provided by Java Enterprise Edition 6. It had all updated features, and also the web profile, which attempts to specify the minimal configuration targeted for the development of typical web applications. It means that all the minimal configuration done through deployment descriptors were avoided or reduced using annotations, and that involved the web profile, which comes in terms of Java servlets as well. So Servlet 3.0, which we will be discussing in this training, it can be 3.0 or 3.1, which is the current version. So basically, the purpose of servlet in JEE, that is web frameworks, servlets are used as an entry point to handle all incoming requests. So it could be said that they are the core elements of web-based application. And this was the reason of inclusion of servlets in JEE. A servlet is a server-side program or a component. It can be used to extend the functionality of any Java-enabled server. The servlets are used to write web application in a web servers to create dynamic web pages, and this is where servlets came into existence for creating dynamic web pages. Servlet lifecycle. So let's brief about servlet lifecycle. The lifecycle of a servlet is controlled by the container in which the servlet has been deployed. When a request is mapped to a servlet, the container performs the following steps, where you can see first the HTTP requests coming to the server are delegated to the servlet container. When a HTTP request is mapped to a servlet, the container performs the following steps. If an instance of the servlet does not exist, then the web container loads the servlet class, creates an instance of the servlet class, initializes the servlet instance by calling the init method. And init method is the first lifecycle method in servlet, which is used to initialize the servlet instances. The init method is designed to be called only once in a lifetime of the servlet. It is called when the servlet is first created and not called again for each user request. This is very important. Init method will be executed only once. The servlet is normally created when a user first invokes a URL corresponding to the servlet, but you can also specify the servlet be loaded when the servlet is first started. Next, it invokes the service method by passing request and response object. The service method is the main method to perform the actual task of any servlet. The servlet container, which is nothing but web server, calls the service method to handle requests coming from the client or browsers to write formatted responses back to the client. Every time the server receives a request for a servlet, the server spawns a new thread and calls service method. The service method checks HTTP request type, whether it is a get, post, put, or any kind of these methods of HTTP, and calls do get, do post methods or do delete appropriately. So this is how the lifecycle methods init, which is called only once in servlet, init method to initialize the servlet instances, and the service method based on the HTTP methods, it will process accordingly in do get, do post, do add, or do delete kinds of methods. Then finally destroys, invoke to destroy the instance of the servlet after servicing the request. So now we know. Next is to know the environment setup for executing the servlet programs. Setting up a servlet development environment involves Java SDK, which currently needs Java 1.6 or above to have all the features provided by JEE6. So set up the Java home environment variable in my computer. Set the path variable with Java home/bin. And step 2 is installing Tomcat. So Tomcat is the server what we are using in this tutorial. So set up the Catalina underscore home environment variable in the my computer environment variable, which is very important. Set the path variable for Catalina home/bin. And also the Tomcat which you install should be of latest version, can be Tomcat 7 and above and not below that, because the new features are listed from Tomcat 7 onwards. Servlet basics. Any programmer should know basics of Servlet. What is Servlet all about? How it works? So already we know Servlet is a server-side programming for generating the dynamic web pages. So let's see in detail the basics of servlets. Servlet is a request and response model. As you see in this diagram, it involves the lifecycle method, service method to serve or receive all the requests and send the responses back through web server. The servlet reside in web server in web container and passes all the requests and executes all the responses back through the web servers to the browser based on get and post methods. The get and post of HTTP are invoked in doGet and doPost methods of servlets. So, HTTP servlets are servlets that respond to the HTTP protocol request, which is used by web servers to return us the requested web pages. We need to extend javax.servlet.htp.htp servlet class to write any kind of servlets. So we should select one of doGet or doPost based on the methods of HTTP protocol. So get request is generally only used to retrieve data, whereas post requests are used for more complex requests like storing data. Next, HTTP basic is also one of the component of servlet basics. Servlet basic involves the concept of HTTP basic. We need to know what is this HTTP all about. As we have earlier seen, HTTP is a protocol which is Hyper Transfer Text Protocol. Hyper Transfer Text Protocol is a stateless response or request protocol that specifies the means of transport as well as the process for maintaining the integrity of those multimedia files. It means that MIME, which we generally call, it is the multimedia file involving multipurpose internet mail extension specifications that describes the transfer and format of multimedia files. And this is how the HTTP request goes to the server and returns the response based on this MIME specification to the client. Next, we have some kind of methods given by the HTTP. We have already seen earlier HTTP put, HTTP get, HTTP post, and HTTP delete. The diagram itself shows put for create and get for read purpose, post for bulk and complex updation purpose, and delete is for delete. To go in detail, a GET request retrieves data from a web server by specifying parameters in the URL portion of the request. So it retrieves the data from the URL portion of the request. If you see the example here, we are asking for index.html and passing the parameter report underscore id. So this is the URL how it forms when you send get method of HTTP. So this, it will show up in URL. Next is the post method. The post HTTP request utilizes a message body to send data to a web server. If you examine the examples HTTP post request below, you will see that we are passing a post HTTP request with the message body, user ID and password to login JSP. Can be any JSP. Here we are considering login JSP. So now if you see the get method, where you can see is you should always use the get method for the sake of reading the data. It means which involves only selecting the statements in SQL which reads the data from the database, and also it is considered for repeated surfing of your internet. And post data is mainly used for large amount of data when it is sent to a web server. You are sending sensitive data such as password, social security numbers, etc. For all these cases, we should go for post. Continuing with HTTP methods, we have put. Put is for loading the data for that resource. In other words, you should know that exact location of where the data you are sending will be retrieved later. The HTTP add is one more method of HTTP. It is used to retrieve information about URL from a web server. The HTTP delete method can be used to delete a resource from a server. So these are the methods provided by Hypertext Transfer Protocol, and these will work with the URL for any kind of request sent from the browser to the server, which we call as web server, for processing any kind of response or request. Next we see servlet specification. Mainly these specifications are from JEE6, which was told earlier, Java Enterprise Edition 6. It involves web framework pluggability. This is one among the specifications provided by JEE6. It means that almost all the Java-based frameworks build on top of servlets. All the web frameworks will build on top of servlets. Any kind of web framework you consider Struts or Spring or JSF, any kind of frameworks will build on top of servlets. So most of web frameworks today plug in either through servlets or through web.xml. Annotations to define some of the servlets, listeners, filters, which will help in making this possible. So basically, this JSR, which is nothing but Java specification request, will aim to provide the ability to seamlessly plug in different web frameworks into web applications. So this is the main specifications of pluggability feature. Next we have ease of development. It is coming through annotations, which is provided as a feature in JEE6 specification. It provides annotations in servlet, use of annotation for declarative style of programming, and also its main aim is to zero the configuration for web application. It means that the deployment descriptors can be reduced or avoided when we start using these annotations. The generics in the API also possible, and because of this language enhancements, all the possible to improve the usability of API is done in this specification. We have something called dynamic registration of servlets and filters, which is done through annotations which are programmatically and then annotate with annotations where we can dynamically register. Before we had through web.xml through deployment descriptors. Next we have asynchronous support. It means that there was no blocking. There is no blocking input or blocking output. None of this were made this possible, like the ability to receive data from a client without blocking if the data is slow arriving. So the blocking in the input is completely stopped using the specification feature, and non-blocking output, it means the ability to send data to a client without blocking if the client or network is slow. So this is very major advantage in this specification, where the resources are not blocked, neither the client is blocked for any kind of operations performed by servlets. So next we have security enhancements, which is nothing but ability to log in or log out, self-registrations, and also provides some kind of annotations, which is again very much useful in programmatic annotations. You can provide all the security rules through your programs. We have miscellaneous. Miscellaneous, it includes better welcome file support. It also includes servlet context, listener ordering, container-wide definition for init parameters, file upload, and many more. There are also threat safety issues which fall into other kind of miscellaneous stuff features. And we will see all these specifications in detail and see how these are achieved and made servlet more attractive and useful in these later versions. We'll see in detail in coming up slides. So next is the servlet API. In servlet API, there are two main important packages, javax.servlet and javax.servlet.http. These provides the interfaces and classes using which servlet class can be written. So any classes will implement these interfaces. Servlet interface is implemented by all the servlets, which is the root of the servlets. So if you see, this is the diagram which depicts the API, generic API for servlet. So you have a servlet interface topmost, which is again following with generic servlet, and then HTTP servlet, which is generally used in all servlets. This is the basic API. And if you see, it's already told there are two main packages, javax.servlet, and in that we have all these interfaces in it. So all these interfaces and classes will provide some kind of features which we will see all these usage in our coming up practical demonstration. Some of it are here, async context, which comes in later versions supporting asynchronous specification, which we saw earlier. This is also very important for non-blocking input or output. Then async listener, this is to listen all the servlet requests. And then we have filter. Filter, it's an object again performing filtering task. And now we have an annotation providing this filter option through the code. We have request dispatcher, which we can send, forward, or include. There is a servlet defining the methods that all servlet must implement. So servlet config, we get servlet configuration information used by servlet container, which is nothing but running in a web server. So the web container or the servlet container needs the information from servlet configuration, and it passes the informations to the servlet during initialization. Servlet context container initializer, again this is related to interface which allows library or runtime to be notified of web application startup phase. Servlet context defines a set of methods that a servlet uses to communicate. These are some, and there are still more many interfaces and classes or methods which you have to explore in this Java X.Servlet package. And whenever we install the basic environment setup, it is very important to even download the API documentation for servlet and know the features or the classes, interfaces, methods given by latest servlet version. Continuing with this, we have javax.servlet.htp package. Even this provides the listed interfaces shown as shown. We have HTTP servlet request. This extends servlet request interface to provide request information for HTTP servlets. We have HTTP servlet response, which extends the servlet response interface. If you have seen in earlier slide, the javax.servlet package will provide these servlet interfaces, servlet request and servlet response. And here in .http package, we extend these interfaces. So finally, we have HTTP session, which provides a way to identify a user across more than one page request or a visit to website and store information about that user. So we'll see more in detail about this HTTP session and all these APIs which we have seen in these slides. So servlet API, basically the JEE6 includes the new versions of servlet API, that is servlet 3.0 or 3.1. This version of servlet API includes several new features for servlet development to make easier, and also it makes easier to take advantage of modern web application techniques such as Ajax. So this is also one of the important features to look for. So ease of development using annotation, which this is one of the specifications which we have already talked about, and this is achieved using the following annotations like @web servlet, @web init parent, @web filter, and web listener, multi-part config. So these annotations, we will see the usage and the purpose of these annotations. So first we have web servlet annotation. So here the web servlet is used in replacement of earlier version which is defined in the web.xml. So here if you see the web.xml, these are the lines which had to be placed in deployment descriptor configuration file, which are completely removed using this annotation, where we directly place this annotation in the class and give the name of the servlet and the class which indicates by itself. So this is so easy made just by using one annotation. We can avoid these lines of code in web.xml. So before going to next annotation, we will look the implementation or the usage of this annotation, how we code using this @web servlet. We'll see this, a small demonstration showing the usage of web servlet annotation. So before that, you need to have all your setup done as shown in earlier slides. You need to have environment setup for Java JDK 1.6 or above and Tomcat version also set in class path. So now servlet is a server-side programming. So we need to create a dynamic web project. So project name we give as hello servlet, and then if you see there is an Apache Tomcat of version 7. We click next and finish. So there is a hello servlet dynamic web project created. So this is the basic structure of any web project. Here if you see, we have a Java resources having source folder in it, placing all Java files, and we have a web content which has meta-inf and web-inf. Web-inf in turn as lib, which has got all the jar files can be placed here. So this is the generic structure of your web project. Now I'll create a new servlet class. So select the source folder, go to new, and then there is an option called servlet. Just click on it. You will get this window or wizard showing to give the Java package. So it's the package name which you have to give. So I'll be giving as InnoBus, can be anything. Once you are done with the Java package, you give the class name as hello servlet or anything. Since we are showing the web servlet annotation, I'm giving hello servlet. And here if you see the superclass, the Java x.servlet.htp is used, which has HTTP servlet in it. So all the servlets will use this HTTP servlet API. So once we go for next, you can see also one of the feature where URL mapping comes into picture. So this is the URL mapping which you give in the browser where you can see the output, and this is what is the URL mapping. You can either change it, edit it or remove it. We'll see the usage of this. Time being, I'm just keeping as it is. Next, if you see next, here you have the lifecycle methods: init, destroy, service. We have do post, do get, do head, do put. We have seen all these lifecycle methods which you have seen earlier. So basically, generally for coding we do get and do post check. So it's already by default checked. So I'll just click on finish. So this is the servlet class which looks like once you create using Eclipse. So by default you get at web servlet annotation, which I was talking about. It gives the servlet name and the servlet name and the class name will be same because I didn't change anything in URL mapping. If you want, you can change here because the servlet web servlet annotation will have many attributes like description, display name, init params, large icon, load on startup, name, small icon, URL patterns, value. So all these attributes which were defined in web.xml earlier can be defined within this web servlet annotation. So now I can show you a simple example of using these attributes. I'll use name as attribute and then give hello servlet as name for this class, and then we have URL patterns used. Where you can specify the way you want to show in URL. Here we have used attributes like name and URLs provided by web servlet annotation. So as we saw earlier, there are still many more attributes which we can see further the usage of it, and we can explore further in our coming examples. So basically here we have defined the servlet name as hello servlets, which replicates the class name itself. It can be anything. The name of the servlet you can give anything, but it is better to follow the class name. And next we have URL patterns. As told earlier, this is the one which represents in URL string, and we can execute using this URL. So once we are done defining this web servlet annotation. As you can see, the lines in web.xml, the number of lines it has got cut down to one single line. It has made so easy to define the annotation with all the attributes required for this servlet class. Therefore, we'll see the usage of the servlet and see some small example like how it works. So in order to see the working, we'll go to doGet. We have seen that doGet and doPost were checked in earlier windows, so these methods have come by default. So what we do here is we'll set the response what we get from the servlet using content type as normal text or HTML. Our output will be normal text or HTML. So I'm using this as a content type. Once I'm done with this, the response, that is the HTTP servlet response object, will give us printer get writer. Get writer, which is an instance of print writer object. So why is this used is, let me initialize the print writer. This is very important because when we use this, it will print all the necessary details what we write on printer writer instance in our HTML page. So in order to show that, out dot, there is a println, print. There are many methods. As you can see here, it's showing print, println. So we use anything to print on the page. Currently, Intel is used and will print hello servlet using at web servlet annotation. Yeah, once we are printing it, it's always better to close it. So we'll see how the servlet works by printing this hello servlet using annotation web servlet in our HTML page. So this is the first class demonstration of servlet where we are using at web servlet annotation for our example with attributes like name for defining name of the servlet and the URL path. So we'll execute this. To execute this, you need to select a class and then say run as on server. What will this do is, the server which is available is Tomcat 7.0, and here when I select this and do next, I have many list of projects already there in this workspace, but currently I have created a new project hello servlet and I'm going to run this, so which is already configured, and this is how we add to the servlet and deploy for execution of the servlet. So we select the list of the servlets here and add it here for configuring or deploying to the server. That is Tomcat server here. And then once I'm done with it, I'll click finish. So when I'm finished, the server will start by itself, and if you see here, it has shown me the output. And did you see and notice this is the servlet name and servlet the project which we have been defined the servlet class in it, and this is the URL pattern, that is which was used in our servlet class, and using this it has shown our output which we used print writer instance to print it in this HTML page. So if you see here, the web server, we have added hello servlet and deployed in the Tomcat server. And once it is deployed, servlet will get executed. So if you see the console, once you start that, the servlet gets started. You see the servlets will start, and after server startup, it has got started. After starting up the server, it will execute the servlet. So our servlet is hello servlet present in hello servlet dynamic web project. And this is the servlet example where you can see how you can create a normal simple servlet using the annotation which makes your code or development very easier by defining in your class itself. Once we are done with this, you can check this example, and also you can see this is the normal connection for your Tomcat. If you want to see if Tomcat is running, just give HTTP localhost 8080 is the port number which by default it uses, and this shows the Tomcat server is run and up for our web dynamic projects to be deployed and executed. So this page will show up that Tomcat is running successfully and it is up for us to execute our projects. Now I've shown you the simple example using web servlet annotation. Next we see what is there in our next slide. Web servlet we saw it. You see there are so many lines. Servlet name, servlet class, and servlet mapping, which is showing you the URL pattern. So all these lines are cut down to one single annotation. And it is so simpler. This is where it comes under ease of development. And next we have at web init parent. This is also one of the useful feature of init parent. Again, all these annotations will cut down your web.configuration file XML web.xml. So this was the earlier version that we showed. So here also if you see there is something called we were in web init param. Here if you see there are servlet tags defined with servlet name and class. Within the servlet tags we can see the init parent tag, and these will define name and value pairs which can be accessed using servlet config. We will see how this config will come into picture, and we'll see how we can access it. And this was the earlier this was earlier version of web.xml, how it used to look like. And now instead of all these things, we can just get the annotation doc doing all these stuffs in the single line. Let's see again one more example in demonstration how it is done. So for that, I'll go back to the same package structure. If you remember, this is the generic dynamic package structure. Web application where we define inside the source I have package, and inside this package I'll create one more servlet. We can call this as web init parameter servlet, because we are demonstrating the usage of web init parameter. It is the same process. I can select the same URL mapping, or I can edit and change whichever URL pattern you want. I'll keep the same. Go to next. By default, these two do get and do post are checked already. It's done, and we are done with creation of the servlet. So any servlet creation in later versions will get this annotation web servlet by default with the name which we saw in that window. It will be same name as your class name. So here I'm not doing anything. The name of the servlet will be this, and also the URL pattern will follow the same. You'll see that how here I'm not giving any, I'm not using it. I won't use any name and other attributes because we have seen already in earlier example. Here we'll keep this as it is, which takes name as well as the URL pattern as class name, that is nothing but by default which we got as web init parameter servlet. Once it is done, to show the usage of web init param. What I'm going to do is, there is something called init attribute. So to use that, I need to use some attributes. So better we go back and stick to the usage of attributes where I give name as web init parameter servlet and URL pattern as keeping the same. I'll just copy paste it. You can give any URL you want. I'm keeping the same. And there is something called attribute called init params. So what does this do? It will take name, which you give as user, and then value will be give web init param annotation. So for that, here it takes name and value as a pair. We can define one more set as such. The name says site and value as http images.net. So this is the basic syntax for the usage of web init param. So if you recall in the slide, there was a servlet tag within which we add init param defined as param name and param value. The same syntax was followed even using annotation, where we have web servlet having the attribute as init params, taking web init param annotation with name and value for defining param name and param value. So this is how we would define or initiate the parameters using at web init param annotation. So after the syntax declaration or definition, we can see the usage of it, how it works. So we can go to do get method. Here it's the same process where the response content type is set to text and HTML, where the output will be shown in HTML, and then get the printer object, print writer object to print on the HTML, which is got using response.get writer method. So once you have this out object, you can write anything using any of the print methods. So here I can write init parameter usage using at web init param annotation. So once this is done, now the next thing is we need to get the parameter value using config object. So there is a method called getServletConfig, and this method will give an instance of servletConfig. So here if you see the servlet config instance is used to get the values defined in init parameter. So we'll see how. Config dot get init parameter. There is a method called get init parameter which takes string as an argument. Here if we pass, if you see the param name was user here. So here if we give string as user, it will return us the value. So it should match the same param name what we have defined. So I'll again use the same thing to get the second param, that is the size inside a variable called. So once I've got both the parameter values, we can output using the out.println saying the first init param, which is the user, is equal to first parameter one, which we have already got this variable. The same thing we used second init parameter, which is the site present in second param variable. And we will give some break statement for proper readability in output what we get. So after using the out object, we need to close it. So this is done. So here what is being doing in this code is nothing but we are getting the out object from print writer using response.getWriter, and after that we are using the getServletConfig, which returns the config object of servletConfig, and using which we can get the init parameters defined in init params using the annotation at init param. So this getServletConfig, the object will fetch the values which are defined even in web.xml. So if you define in this way in web.xml, for that also we use the same getInit parameter to get the values for param names. So this is how we get it using getInit parameter. Now we'll execute this. Just right click on this and say run as run on server. So it's the same thing. It's already been deployed, so it will deploy to the server and the servlet gets executed with this output. So here this has to be ended. So that was the header. Now if you again run this, see, this is the output what you get. Init parameter usage using at web init param, what we have given in out.println, and the first init param user value was inobus and the site was http://inobus.net. And how was this got? Using servlet config get init parameter. So this get init parameter will return you the param name value by just passing param name to it. So you have just defined within the class using this annotation and accessing using this config servlet config instance using get init param method. So this is the example for this annotation. Now next we'll see what is there in our slide. We have seen how this works. Web init param and replaces this code in web.xml. We can even use web.xml if we don't use this annotation, but this annotation will make the development easier, so we can go and use this as shown in the syntax which we saw just now in our snippet. Next is the web filter. Web filter is the annotation which says that filter were introduced to the servlet specification in earlier version. The description of filter says it's an object that can dynamically intercept a request and manipulate its data before the request is handled by the servlet. So therefore, the filters can also manipulate a response as well. So after the doGet and doPost method which finishes, but before the output is sent to the browser. So this is how filters will work. The filters will allow the universal functions to connect to the servlet or the web resources. So we had the filter definitions defined in web.xml. As you are seeing in this slide, we had a filter tag which add filter name, filter class, and then filter mapping. So these lines of code were defined in web.xml to use the filter in servlet. But now using web filter annotation, we can replace this complete code within the class. So let's see the demonstration of web filter. There is already a dynamic project created. This will show you the sample or example of usage. So there is a package web filter within which there is a simple filter class. So here I have already created a class with annotation web filter. So how do you create a web any filter class? Is very easy. Just select the package and new, if you see there is a filter class in it. So once you create this, you will get a class generated like this with annotation annotated with web filter. It takes filter name. Again, it can be anything, but here it is same as class name. And also it has got an attribute. Even web filter has got set of attributes. We can see all of them. So these are all the attributes. It is same as web servlet. And here in init param, we have again defined web init param, which we had seen earlier. So here, this init params are for filter and not for the servlet. So if you see the slide again, we have something called filter name and filter value to it. So for using that, we need to define this init parameter attributes with web init param, which takes name and value. So here we have just given filter param 1 name and value as filter value 1. So this is just to demonstrate one set of web init parameter is defined. So after which followed is the URL pattern. It is the same usage. You can see or execute this URL in your URL string when you run the servlet. And once it is done, this class, any class you create as a filter should always implement filter interface. That is very important. Though you use @web filter annotation, we should also implement filter interface. So there is a filter config already been declared and initiated in init method, and there is a do filter method inside which we do filter config. That is, using this instance we get servlet context object. So this filter config will give us the servlet context object using which we can log the statements inside the console. So this example is just to show how to access the filter names or filter init parameter names. And here we are just getting the servlet context using filter config object and logging it by some statements. So here the statement is entering do filter. We have entered the do filter method, so it's written as entering the do filter method. And after that we are logging initialization of parameters. So here filter config has got get init parameter names. This is the method which we earlier saw in servlet config. So here it is a filter config. This will return you the init parameter names. So we have just defined one name, that is filter parameter name. Here again you can delimit with comma and define n number of filter parameter name and value using at web init parameter. So here there is one. So using this enumeration, it has been iterated and it just prints or get the next element and logs it in servlet context object. And once we get the parameter name and value, here if you see the parameter name is nothing but the filter name 1, the filter param 1, and value is filter value 1. So this is got using get init parameter of filter config instance. So after getting this, we are just logging it again, invoking the servlet, which in filter chain is coming from this method itself. The do filter signature of this method is it takes servlet request, servlet response, and filter chain as a parameters. And this filter chain we can have do filter again invoked using servlet request and response object, and finally logging back from servlet invocation. So this is the simple demonstration for showing our web filter annotation. So we will just execute this and then see the output. So if you see the method in filter class, we have do filter, destroy, and init. These are all the lifecycle methods of filter interface which comes when implemented by your user defined class. So as I said, when we use @filter as a web annotation, we should always implement filter interface which will get all these lifecycle methods. So within which in do filter we have logged some statements and got the filter parameters using filter config object and get init parameters. So when we execute on run as server, so in the web browser you can see here it doesn't show anything. If you remember in simple filter we are not doing any out.println statement, or we are not printing anything in HTML. We are just logging in console. So all these log statements will come into console, that we are not printing anything to the HTML. So therefore here we won't get anything, whereas in console if we see whatever is logged, we can see here I'll restart the server again and run. Here we have two things, so let me remove all the web projects and execute only the simple filter. So here if you see the URL should be init param servlet. So this should match with the URL pattern what we have defined here. So in this class, though the class name was simple filter, we had URL pattern as init param servlet. So therefore, we need to give that and then run this. So once you execute this and then check with the console, here you can see all the log statements what was written to the servlet context object. So here it's starting with entering to the do filter method. So this is the log statement, first log statement which we gave in the class. You can see here, if you recall, in do filter method, there was a log statement, first one, do filter entering and then followed with initialization parameters. So the same thing you can see in this console. So it is initialization parameters followed with filter param name. Param 1 is the filter value 1. So this is the output of the example, which is giving the param name as got the value as filter value 1. If you see the definition and recall in the class, we had given in web init param name as filter param name 1 and filter value 1 as value. And this we are showing using the log method using servlet context object. So once it is done, these are followed, that is invoking servlet, where we invoke the do filter using filter chain object. So if you see the console again, once it prints in the log, it says invoking servlet, and after invoking the do filter, it again says back from servlet invocation. So this is the simple example to show how the web filter works. So next we'll see what is there in our course. Next is the web listener. So what is this web listener all about? So web listener was again one of the tag replaced in web.xml called listener. So this was again mentioned in the web.xml. Instead of giving a deployment descriptor, that is web.xml, we can give using web listener within the class itself. So what is this web dot listener all about is nothing but during the lifetime of any web application, we have a number of events taking place, such as HTTP requests, which are created or destroyed, request or session attributes are added, removed or modified, and so forth. We have many events happening for this HTTP request. So when these events happen, there are many listeners interfaces provided by Servlet API to handle these events. And all these interfaces are there within Java X.Servlet package. And here you can see the list of listeners which are there within this Servlet package. There is Servlet Context Listener. So here it says it contains method for handling the initialization and destruction events, and there is servlet context attribute listener, servlet request listener, servlet request attribute listener, HTTP session listener, and these HTTP session listeners are used when you have HTTP session initialized or destroyed or removed. So that time you have these listeners invoked and handling the events. So like this you have many events handled using the listeners. We will see one example using this annotation. So for that, what you have to do is either you can go to new project or you can use the existing one. So let us create new project. So project name will be web listener. So here when you go, you are done with creation of listener project. So this is the basic structure. And Java source resources, you have source folder. Here I'll create new. You can have a package created. and within which you can create a servlet listener. You have an option of listener class creation. You have a servlet, filter as well as listener. We have seen other two. Now we'll see listener. So give the class name as web listener servlet. So once you do next, here you can see the listeners which were listed in the slide earlier. All these are the listener interfaces which are there in JavaX servlet package. And all these are handled whenever the servlet is created or removed or destroyed. We have a servlet context listener to handle the events. We have HTTP session events to handle whenever the HTTP session objects are created, removed, or destroyed. Then there are servlet request listeners whenever the events occur for servlet request. So all these listeners will come by default, and based on your requirement, you can implement any of these. So here we can go for servlet context listener for an example. I've checked that, and once I'm done these next, so it will get that interface, and after finish you can find the lifecycle methods context initialized and context destroyed. And here if you see this class what we have defined will implement servlet context listener. You can implement n number of listeners by comma as a delimiter, and also handle all the events within the same class. So here you see, since the listener class was created, the art web listener annotation has come by default to this class. So here we can just see how it works by just giving some kind of uh, log statements. So here this argument what you're seeing is an instance of servlet context event. Now this instance has got get servlet context as a method which can return servlet context object. So servlet context object is generally used for logging things. Here since we are trying to log the statement whenever the servlets are created and initialized, so what we do is context dot log, just say since it is initialized we can say new request has been initialized. So whenever any servlet has been initialized, this this listener will invoke this method to handle this. So after this can give the same set of statements even here to show whenever the servlet is destroyed. So here we can say servlet has been destroyed. So here instead of saying servlet we can tell request, because it's a servlet request which will get removed. So once these are done, we can see the invocation of these lifecycle methods whenever there is an initialization of the servlet, because we have implemented servlet context listener. Servlet context has been object has been used, and once it is done, we log the statements to check the result. So let's run on this server. So web listener has to be deployed in server so that we can run this class. And once you run this, you can see the output here. You see new request has been initialized. So since the request has been initialized, it is showing us this log statement what we had given here. So the same if we run again. So it will give n number of time the moment it has been initialized. And since it is not destroyed, nowhere it is showing up the destroyed log. So this is how the listener will listen to the event whenever the context has been created based on the listener interface you implement in your class. So this is the simple example what we saw by logging the statements to the console. Next, we'll see what is there in our course. So we have seen all these listeners, but based on the requirement, we can implement one or more listeners to your class or one at a time based on which listener you want to implement. And next is multi-part config. So multi-part config is another example or usage of annotation for easy development. Now, why is this annotation used is, for example, in Servlet API earlier versions, it did not provide any built-in support for handling file upload, which were used for various open source libraries like Commons file upload or any cause of multi-part parser. However, supporting file upload is so common in any web application. Therefore, the Servlet 3.0 specification supports this in out-of-box way, where the web container itself can parse the multi-part request and make MIME attachments available through HTTP Servlet request object. So this is the new annotation which was introduced in Servlet 3.0. So therefore, in this, it says it can handle multi-part or form data request of servlet as it is told. So this is the later version inclusion which give very much requirement for file uploading, and this is very useful feature when we do that. So this involves attributes which are very important attributes which are required during usage of this annotation called as location. In this location, we give absolute path to it directly on a file system, which is important to remember that the location doesn't support a relative, it just supports absolute path. Therefore, the location will be used to store files temporarily while processing parts. When the size of the file is bigger than big file size threshold is true. Therefore, the location part will give an absolute path, and max file size, where we mention the maximum size for file uploading. Default is -1, it means unlimited. So max request size, this attribute describes the multi-part or form data request, which is the maximum size. So therefore, the request size, it will tell the same. The file size threshold. So this file size is in bytes, after which the file will be temporarily stored on disk. Now you can see the sample demonstration with the usage of these attributes, how the file upload feature has been given in Servlet 3.0. We'll go to the demonstration. So here we have I've already written on or created a project called multi-part config, within which there is a package, and inside that there is a class. The class has been named as file upload servlet, extending HTTP servlet, which is general. Any servlet will extend HTTP servlet. The unusual thing is the usage of multi-part config, and we know the usage of web servlet where we have given upload.html, and we will know how this will work. So we have seen all the attributes of multi-part config. The location attribute, which will give the temporary path of your absolute location path. So here the C drive, there is a temp folder. So I have given this folder just because whatever the file will be created after execution of this class will be placed inside this temp folder. And size threshold. So this is given in this, and then max file size you can define based on your requirement, and max request size. So these are the random numbers which are given for the size. Now here we have do get, in which we get the servlet context, dispatching or forwarding to the JSP. There is a JSP file added in this path. We always add, if you have seen in earlier discussion, the pages which will be added, or the JSP pages which will be added for web applications will always go inside this web INF folder. We can give any name for this folder within the web INF, or we can directly place this form.jsp inside web INF. But since to segregate the files, we can give, to be more readable, we have created one more folder pages and then given a JSP file. So I can show you the content of form.jsp. So it just has got one text field, that is input as file, type as file, which will browse the file. So if you see the input type is file, so it will take the absolute path of the file name, which is a feature of HTML, and after that there is a button to submit. This is just for to show how this example works. The usage of JSP is only that, and this will be invoked at do get. We are dispatching this and forwarding the request. In do post, there is the response. We are setting to text HTML. This is the normal statement where we write, and the output will be in terms of HTML. The out object, which is a print writer, is used to print on the HTML. Here the request, which is the HTTP servlet request dot, there is a method called get parts. So this method will get all the parts which are used in file definition, and then we can get it using that through collection. It's collection. It's a object used for collecting all this information. So after this definition, we iterate this using part class. So this part class, if you see, it comes to the package javax.servlet.htp.part. So using this part, each one will be a part. So there is a custom defined function where I have defined to show the part content. We have get name of that file, to get the content type of that file, what is the content type, to get the size of the file, and then the header names. So all these are the basic things which can be shown as an example. So here the part has got all these methods to get the details of file what we are going to upload. So once we are going through the parts, and then we are writing that to the new file. So this is the sample file which will be created on fly, and then return the contents of the file which we give in this location. So basically all the contents of that will be written into this new file name. The file name you can specify anything. Here the sample file name has been given. So part has got the method write, in which it takes the file name into which the contents will be written. So we'll see how it works, then it will be a clear picture. So we can run that. So here right click and then run on server. So you're just adding multi-part to the server to deploy. Asking to restart server. So once the server has been restarted, you will get the form JSP. If you remember, that request has been forwarded to the JSP page because we are including the JSP page for user interface and proper demonstration for this example, which will show one field of file type and to select the path of file. So here, this is the file which I have been just created for the sake of this demonstration. I'll show you the content of it. So it is there in this path. It is there in C drive. Text, there is a folder created for it, and sample text. So you can select any file. So just for this example, there is a file created. You can select that and upload the file button can be clicked, on which it will go to upload.html page, and then it will give what is the file, first file name, and then the context is text or plain. And if you see, the total part was 1 because only one file was uploaded. And the size of the file, something is there inside that file, we can see what is there. And then the rest of the thing is the file name which has been created is the file name which we uploaded is sample.txt, and we can see where it got uploaded. So before that, this is the folder where the sample context was placed. Sample text file which was written example demonstration for at multipart config. So this file content is written inside the C folder temp sample file. If you see this, you can see the same content has been written and uploaded. So this is the absolute path which we gave in the class file to place the file which was got uploaded. So here if you see the example again, the location what we give is the location where we place the file to get created. And here if you see, the sample file was the name of the file in which it will write. And this name of the file created will be placed in ctemp, and the content will be whatever the file we will upload it. So we just uploaded, and that after uploading we'll get the details of that file using get parts, and within the get parts we can get the file name, we can get the header name, and also the size of the file and the content type of it. So you can see all of it. This was the file which I uploaded it. It just wrote it into the new file called sample file. This was created and written within this absolute part what we gave in the location attribute of file upload servlet class. So this multi-part config will give the feature of uploading the file and writing the file content to another file in the specified location. So based on the size, min and max size, it can write, and this is the simple demonstration of it. So all these will come with part file which you can get it using HTTP servlet request object. Using this object we get parts, and within which we can get all the details and write into the new file. So here if you see, everything will be written into the new file. So we have seen the demonstration of usage of multi-part. So next we'll see what is the course saying in next slide. Is asynchronous servlet. Asynchronous servlet, it means that asynchronous processing, basically asynchronous processing avoids blocking request by allowing the thread to perform some other operation. So there will be no deadlocks. So the blocking will be avoided using asynchronous processing, where meanwhile the input is written to the client. So there will be no blockage when we use this concept of asynchronous servlet, which has come in later version of 3.0. The asynchronous processing allows the thread to issue a call to the resource and return back to the container without getting blocked. So the thread can perform other tasks, which makes servlet 3.0's performance more efficient. So any asynchronous servlet will be more efficient than synchronous. So implementing an asynchronous servlet requires using the async context, which can be obtained from HTTP request object. So this is one of the specification which we had seen, the feature of asynchronous in the servlet. So once we are done with that, we'll see what is there in our next slide. So the next slide is Servlet API, where we have about security. So what is this security all about? So security in JEE is specified using @servlet security, which has come as a feature of JEE 6. So before knowing that, we have types of security mentioned in JEE. So in multi-tier enterprise applications, several containers are needed to deploy various components of enterprise tiers. So these containers also provide security to these components. So anything deployed in a container, the container implicitly will give security to these components. So there are two types of security basically, either through declarative security, where we do normally using web.xml or annotations, or there is another way, programmatic security. When declarative security is not enough to hold application security model, programmatic security is employed. So there are two ways, declarative and programmatic. So now we have seen this, and we are going to see @servlet security annotation, which is used to define security for a servlet. So this annotation is alternative mechanism which we achieve through security constraint, the tag which we give in web.xml. So this is the alternate where the annotation has come. And here we have two methods. This method provides us ability to define specific constraint. So we have @servlet security annotation, which can be implemented using following annotation. So this will implement along with either of HTTP method constraint annotation, which will apply only for particular HTTP method, or it can also implement using HTTP constraint annotation, which applies to all HTTP methods. So basically the sample code will be like this. It is same as others. You can give a class level annotation definition, which takes web servlet, which will give the name of the servlet as we have seen earlier, and this servlet security annotation taking two parameter attributes. First of all, it implements either one mentioned above, HTTP method constraint or HTTP constraint. So here in this example, we are seeing as HTTP constraint taking attribute transport guarantee. So what is this transport guarantee means? it will define whether or not SSL or TSL is needed. SSL. So here it tells that. So here, based on the protocol itself, it's confidential. Then the connection must satisfy these protection requirements. So based on this legal values, none or confidential. So here it is confidential, and the role allowed, the element who is employed to define the authorized role name. So here in this example, tutorial user is the authorized person to access this confidential information. This is the security feature which is also one of the specification defined in JEE 6, Java Enterprise Edition 6. So next what we have is session management in servlets. So let's see something about session management. Session management comes into picture when we require to maintain number of requests requested by the same client to associate them. So in this case, session in the sense that to maintain a client stability. So therefore, we go for session management. So in Java Servlet technology, there is an API which helps us to do this. But before that, we'll see the session tracking mechanisms. If not servlet, there were other features or mechanisms also for doing this session management. We have something called cookies. Cookies are mainly used for associating a session with a user. Various of mechanism who is used by the web container, which is passed as an identifier between the server and a client. So this identifier identifies the client by matching the same identifier which are sent by server back. So this information of identifier is stored in client side, which is called as cookie. So the web component identifiers can be included to every URL which is to be written to the client by the server. So this is the concept of cookies, which will be communicating between the client and server to know the association between the user. Next, if what happens is the cookies is turned off on certain client side. In many of the client machines, they turn off the cookies. So in that case, maintaining the session detail will be not possible. So there we go for URL rewriting. So here what it says is it will enable the session tracking by application rewrite URLs using encode URL method of response, which can be used for such purpose. So here what happens, it will encode within the URL what is sent to the server. So whatever we send the request URL, the server will send the session ID within the URL, encoding the ID in it and sending back to the client whenever the cookies are disabled. So URL rewriting can also be used, but generally we go for session management, which is done using servlet. So we'll discuss that in further slide. Servlet session. So servlet session, which is very much required, which we can get it using get session method of request object, which is used to find out HTTP session object. So this HTTP session object will give get session method. So within this we have a listeners binded to it. Whenever to notify the object of its association with session of their event, we have HTTP session binding listener interface as well as HTTP session activation listener, which can be used whenever the session will be passivated or activated through activation, or when session is added or removed through binding listener. So these listener will indicate whenever the session is created, added or removed, or activated or passivated. The session object, how it can be managed using the session object? We can do this by using two methods. Get max inactive interval. This method is used to find out maximum time interval that a session will be accessed between the client. Set max inactive interval. This method is used to specify the maximum time interval that the request between the client before invalidating this session by the servlet container. So if you do not want the further interaction of a particular client interaction is completed, you can invalidate the session on the server side using the invalidate method as well, which is again one more method provided, and also delete that session data. So therefore, each session is associated with timeout because HTTP session has no any mode to inform that the session is no more needed. So managing session timeout are done using these two methods. Next is the servlet context and servlet config. Servlet context. So it is a public interface which is implemented by the servlet container for all the servlets to communicate with the container. So this context, that is servlet context, is used by all the servlet which is there within the container. It is applicable only within a single Java virtual machine. And if you have other Java more than one, it won't be applicable. Whatever was there in your servlet context will not be available for another virtual machine. So it is one for one JVM. The servlet context object is contained within the servlet config object. We have already seen how servlet config is used. You can specify the param value pairs for servlet context object using context param tag, which will be found in web.xml file. And this is the example code which shows you exactly the syntax which are there in your web.xml. There is no annotation defined for this servlet context, whereas we had for init param tag which was there within the servlet tag. For that we had annotation called web init parameters, but there is no annotation yet for servlet context. Therefore, these code need to be present within your web.xml. We'll see more in detail while showing the demonstration. Servlet config, even this is a public interface. This is implemented by the servlet container to initialize only a single servlet using init method. So this will be used only by a single servlet. And you can pass initialization parameters to the servlet using web.xml deployment descriptor, or you can also pass within the class using the annotation web init parameters. We can see the usage of these two, context and config, in our demonstration now. Create a new dynamic web project. Give the project name, servlet context and config. So once you are done with that, click next. Here, if you see here, generate web.xml deployment descriptor. Once you check this, it will default create the web.xml for you. The reason of using this here in this example is we need to show the implementation of context param. So let's create one web.xml file. Once you click finish, you can see here, this is the basic structure of web application, and the web.xml is created within your web.inf folder. Once we are done with this, let's create a servlet class. Give the name as context and this should be the package. So your package should be Unibus, and name for the class can be context and config servlet. So once you are done with that, say finish. So this is the class which will get generated, and here now let's give the name. The attributes usage which we have seen in earlier classes, you need to give the servlet name and the URL pattern. So once you are given the URL pattern, we are showing the demonstration for servlet context as well as servlet config. So for config, we can pass the parameter values from this class itself, and we have already seen in earlier course there is an annotation used at web init parameters. So before that we need to have attribute there should be comma separated, and then define this with at web init param. So within which you can specify the name equal to user, can be anything. This will just give as user, and value is InnoBus. So this is the definition for accessing the init parameter values using servlet config. So what we'll do is we'll go back to do get method, within which we have something called get servlet config, and using this instance there is a method called get init parameter which takes string, and here what was the string given? It was user, and this will give the value for it. In order to print this, we need to have an out instance which is print writer, so that is got using HTTP servlet response class method which has got get printer, get writer. So this will be an instance for print writer. So once we have got the instance, we can print the same what we have got using the print writer instance, println method, or any method which you want to use. So here we can state telling the init parameter value of user is. So what will be the value? You can directly copy this or cut this, or you can initialize to some variable and then use that. So this is the basic syntax or the code which we access the init parameter using the at web init parameter in annotation. This we have already seen, and for accessing those init parameters we need to use servlet config get init parameter. So this is the interface all about, where we have servlet config usage which is done for per servlet class. And now to see how servlet context works, we need to first define some of the context name value pair. For that, go to this web.xml which was created earlier. There is a context param tag, inside which you need to give param name and param value. So name, let's give us first name, can be anything. This is just an example to show. First name we are giving as a param name, and param value can be the name. Let's give some Jeff or something. So if you see this within the web app tag of web.xml, you can define the name value pair for the context parent tags. And to access this within the servlet class, we need to have getServlet context object, and using this there is getInit parameter which will return you the name. See, if you see, there is one more method getInit parameter names, and we can at a time fetch the values for all these names and enumerate to show the result. But here we have only one name defined, so let's access only one. What was the name given? It was first name, and this will give you the value. And to output this, same thing, out.println. So what will be here? The init parent name will be first name. And then instead of config, we can access the context parameters using context. So the init parameter value here, it's not init, instead it is context, which is accessed using servlet context getInit parameter method. So we need to save this file web.xml, and this name will be used to fetch your value of your context parent value. So once you're done with this, what is the next we have to remember? Close the print writer. So we are done with the demonstration for servlet context and servlet config. So let's execute this. For that, run the servlet on server. So we have this project which will be configured and deployed in the server. Server will get started and show you the result in the web browser. So you can see here the init parameter value of user is InnoBus, which is got from the class itself. If you see here, we have defined the init parameter param name as user, and the value is this. And this is got using servlet config object with method getInit parameter. And if you see, the context parameter value of user is Jeff. So this value is got from web.xml. The context parameter is fetched from web.xml using servlet context instance, which as method getInit parameter. So this is how you fetch, and also remember the servlet context, whatever is available as a value and name, you can access for all servlets which will be provided within the servlet container, and you can communicate with the servlet container. And it is one per Java virtual machine. So this will complete our demonstration for context and config. So let's see what is there in our next course. We have advanced features of servlet. So what are these advanced features? Some of it are request dispatcher include. So the include will include the request and response, which is the method of request dispatcher used for including the another resource, content or information. So within the servlet class, if you want to include the content of the resource which is present externally and you want to include within the same servlet, you can use this include, which is provided by request dispatcher. There is web servlet request dispatcher forward. This is again one more method by provided request dispatcher, which provides saying that it is used for forwarding to another resource or web component. And there is send redirect. So this is the method of object HTTP servlet response. So request is redirected to the client and it will process the new URL. So here if you see, whenever we use the send redirect, it will process as though it is a new URL. It will be redirected back to the client again, and the new URL will be opened whenever we use this send redirect. So end user can see on which page URL is redirected. So these are some of the advanced features of servlet. We can see how these work using some small demonstration. Let's create a new dynamic web project again. Here we can give the web project name as include, forward, and send redirect. So once it is done, finish, the project has been created. Let's create a servlet class. So this should be the package. So once package and the class name is given, click on finish. So the servlet class has been created. Here we can go for do get. We need to include the content or the information from other resource. Resource can be the servlet or the JSP or HTML. So let's demonstrate the include feature using JSP file. So there is a request dispatcher which is coming from HTTP servlet request dot get request dispatcher. So what will this do is it will take the file where you have to get the content from. So since we are talking of inclusion, the content from JSP file, let's create some JSP file within the web content folder. So you can give the file name as include.jsp. So once the JSP has been created, you can just give that this content is from include.jsp. Once we have saved it. Now here, as I said, you need to specify the JSP file. So include is the JSP file, give that path, and then invoke include method of it, which takes request, that is HTTP request, and response, HTTP response instance. Once you are done with this, you can see how this include work. What will this line does? It will include the content present in your include.jsp within this servlet execution. We can execute this on the server. So here you can see the include method of request dispatcher has got the content from include.jsp. So this is how include works. Now let's see how the forward JSP work. That is, we'll create one forward JSP to see the forward method. Let's create that first. A new JSP file, you can give the name as forward. So again here you can put some content to just see that this is from forward page. Now in order to forward the request to that JSP, what we have to do is we just need to call request dot get request dispatcher, because include and forward are present within this instance. The request dispatcher class we have already seen. This will provide these two include and forward methods. So this will again take the string value for your file name. Here the file name is forward, where we have to forward the request. Just specify the file name path and then forward method is present already. So this will be HTTP request and HTTP response. So now you can see how the forward method of request dispatcher will just forward from current servlet to the forward JSP. So we'll see the invocation of this by running on server. You have to restart the server because you have made changes in servlet class. And if you see here, the forward servlet has just been forwarded to this JSP page. So the request dispatcher class forward method will dispatch the request to the resource. It can be the servlet or the JSP or any URL which you give here. So currently we are demonstrating using JSP files. So this forward method of web servlet will forward or dispatch the request to JSP page called forward. And now we'll see how the send redirect will work. In order to redirect, we'll create one more servlet class. Name this as redirect servlet. Once you are done with, you'll get this simple servlet. So in order to know that this is the redirect, we can use response.getWriter method to get the instance of println, so that within this method we can output the message telling this is redirect servlet. So we'll see how this works. This is just a simple servlet class where we have just written this statement to show the redirect page. Now coming back to the servlet class where we have demonstrated include and forward, we can remove these. And also note that if you want to add or retain the same, you can't call forward and then redirect because forward will completely forward to the next page. So in order to avoid that, you just redirect the page within the method before forward method invocation. So where will you get the redirect method? It's there in the response dot send redirect, which takes the complete package of your servlet class. Here what we are doing, we are redirecting to this servlet. So where is the servlet? There within this package. So let's copy this package name as it is, and here in calling servlet, the package path as well as the redirect servlet where we need to redirect the request need to be given. So once it is done, just enclose this. So this line, if you see this method, do get inside which we are calling redirect, which will redirect the request to the servlet, another servlet, or it can be another JSP, or since it is redirecting to the servlet, servlet will further take care of logic present within that servlet. So any URL which has to be redirected back to the client with new URL, then you use send redirect method coming from HTTP servlet response. So you can also use redirect from session, which is there from HTTP session. We have seen in earlier slide, but here we are using this response from HTTP servlet response to redirect the request. Now save this and we can execute this class. Run on server. So here it says we cannot forward the response which has been committed. Therefore, as I said earlier, we need to remove these forward tags so that the send redirect will completely go as a new request to the new servlet. So it will act as a new request. So after which we can't call any forward or include method. So once we are done with, save this file and again run on server. So here you see the output. This is redirect servlet. So it has been redirected to the path which you have given for the servlet where you have to send the request, and this will be treated as a new request, and you can see the URL within this page which shows you the URL of your new request direction which has directed to your new servlet, redirect servlet. And this completes the servlet course. We have seen so far all the servlet features, servlet lifecycle, and also the introduction for web development. Thank you. Here we come to the end of this training. Thank you.